Welcome to Lab 13 on hurricanes. Quick note as we begin and start part 3. We're looking at the abbreviation for National National Hurricane Center, and they are going to accumulate multiple models of data and determine what they consider a good number or the actual standard or what they believe will happen based on the accumulation of models. So they use margins of error and model out the actual information. Which brings us down to question 12. Describe the historic error trends for each forecast's lead time based on 24 hours, 48 hours, and 72 hours. So up here in the image above, we have the margin of mileage error. This is how far off the projected paths were for various years. And so down below, this part of the scale, we have years. Over here is the margin of error in your set of miles, and over here it is in kilometers. But it's the same information, just kilometers or miles, depending on which side you look at. The 24 hours is the baseline in the very dark color. The 48 is the dotted line. And the 72 is the thinner solid line. And you could see that 72 hours out, historically, we've had a pretty tough time determining what's going to happen. At the 72 hours out, it really wasn't till the late 80s that we really started getting a handle and being able to project storms. So you can kind of see that, like 1985, how much cleaner we got at projecting models at the 72-hour range. At 24 hours, we've been pretty consistent, and it's actually gotten even smoother since the late 90s. So right here around 98, the 24-hour line had gotten really smooth, really consistent, right? Same thing with the 48 hours. We got really good, and that really has to do with satellite data. And so you're going to describe some of these historic trends, just point out some different points. You're welcome to label the image and reference those labels, so labeling them as that, or give them year dates and say 1985 in the 72-hour line. Historic mean mistakes were made at maybe 350 miles. You know, something like that, but be really exact, because this is good science to be good and exact. So now I will meet you over on the next page. Even though we'll be referencing the information for this image, we're going to be looking at the question on the next page. All right, so question 13, how would you characterize the relative range of paths forecast by various computer models on August 25th? And so we're going to go back a page to that 25th map. And so all of these are the projected models for Katrina, and they're projected on different dates. The dots are the models. The solid line is what the National Hurricane Center said will happen. So they took the average of the different models and their different margins of error, and they created what they believe will happen, and that is what's in the solid line. So for question 13, they're asking you to characterize these various computer models. Characterize means to come up with some descriptive terms. One of the things that we could say for sure based on all these models is that the storm is going to start out by moving in its easterly towards the west, so it's moving in its easterly trade winds. So it's going to move from the east to the west. As it begins to go westward, it's going to turn and pull poleward, right? And every single model does that. They're doing them on different shaky lines, but they're all doing exactly that. So create some type of characterization that describes what's happening on this image. Question 14, how would you characterize the range of paths projected on August 27th? Let's go back to the 27th page. Oh, no, 27th is on the other. Sorry, 27th is right here above. How would you characterize these? Well, this is Katrina and how we think it's going to move based on the 27th, and we can see it's still doing the same thing, but it's much broader, and that the model is more condensed, it's more exact. Every single one of those models are pretty much spot on to what the projected outcome that the National Hurricane Center puts out there, but use some description to describe what those models look like. And then question 15, between which two consecutive days do you see the most dramatic shift in model predicted path? Which one, between which day and which day, do you see the most change between the four images? Based on the image on the 28th, 27th, the 26th, the 25th, or the 24th. Which one changes the most? So that's you answer that question, you would say maybe you feel that it looks like it shifts and becomes really different from the 24th to the 25th, or you think it looks really different from the 25th to the 26th. We'll tell you right now, you shouldn't feel that way about the 27th, 28th, because they're very much similar. So that gives us the answer to 15. You pick which day to which day had two very different models, so that there was a real change in the storm. So now looking at question 16, consider the hurricane that creates a swath of damage at 185 kilometers. This is about 100 miles wide. Completely within the average size warning area. What fraction of the warning area would have to have a false alarm? So, if you were to put out your standard warning, right, and you had a standard width of a 100-mile wide storm, what percentage, or what do you think is the average number of people that would have false alarm based on these type of projected miles? And so what they're trying to do is get you to look back at something like 1316. So now I'm going to look at this image. I'm going to create this sort of like marker. So I put these two little T-bars in to kind of depict where the swath would be, because you want to have that 100 nautical miles away from where you think that'll be. And so these are all my projected models. So somewhere in this yellow region we're expecting the storm to be, and then you have these outwash zones right on this side and this side that could potentially be hit with the storm. But they obviously didn't end up being. The storm kind of went almost where it's projected in this image. It's pretty much on this true flow. So knowing that, how much space was in the wrong region? So I'm going to try to highlight in the yellow and give you a feel for, this area, right? So this area here was where they actually got hit. And then this right here to about here, not quite in there so much. Well, that was a big highlighter oopsie with my eraser. Kind of to about there. Didn't end up being in the storm. So those little black areas, what percentage would that be? If this is my line of 100% from here to here, you would say that this is maybe 20 or 25. This would make up maybe 10. So I'd say about 30% to 35% were in the margin of error who did not get hit with the storm based on this image. If this line is my 100% mark, this makes up about 20%, and this makes about 10%, right? And the rest of the people in the middle in the yellow got hit with the storm. So that would be how I'm setting up my math. So I'd say 30, 35%, somewhere in there, would be in the margin of having reported potential hurricane winds and not actually getting hit with them. All right, so I showed you how to do question 16. So for question 17, during the periods of 1995 to 2004, the National Hurricane Center average 24-hour forecast had approximate errors of about 140 kilometers. So that means they were off, or they made a mistake of 140 kilometers, or 75 nautical miles. At the 48-hour mark, so 48 hours before the storm, they would average being off by about 255 kilometers, or 138 nautical miles. So that means that they would be off, or that areas, those regions would be wrong. So in the image below, you're going to be looking at the 48 hours for Katrina, and then below that the 24 hours for Katrina. And you're just going to talk about how far off the projected path was from the actual path. And keep in mind, in these images, the dotted lines are where Katrina actually was, and the projected paths for the Weather Service are in the dark gray images. So you're looking at the dark gray for what the National Weather Service said was going to happen, and the dotted lines will be in the actual path of the storm. So now doing kind of what we did, and your scale is right on the maps, determine sort of how far off the guesses were based on that image. And it shouldn't be much, because as you can tell, the scale, they are only off by a couple miles. So you're kind of zooming in, looking very, very closely, and my image is much too cloudy for me to help you measure on here. And you're going to try to figure out how many miles off the actual storm was from the storm projection. Just tell me how many miles away. So you're zooming in on the image, or in your case, you guys are going to look really, really closely, and you're going to take a guesstimate as to how far apart that is. How many miles of mistake was that? All right, so on that note, you will be all done with lab number 13. Congratulations, and you can hand in your book, and I will grade things up. And you will have a wonderful rest of your day.